Hello everyone. What we're going to do today is look at the charging and discharging of a capacitor. You can see the theory there. You can pause the video if you want to read that. It's on the sheet that has probably been made available to you. This is the circuit diagram that I'm going to use. I'm actually going to replace these two switches by a single SPDT switch. That is a single pole double throw switch. So here's the circuit. You can see I've got two resistance boxes. I'm going to discharge the capacitor through a 100k resistor and then charge it through a 47k resistor. I've got a capacitance box as well. I've taped over the value. The purpose of this practical will be to determine the value of capacitance using what you've learned. What we're going to do is I'm going to turn the power supply on. And actually, I'm just going to double check. In fact, the capacitor is fully discharged because, in fact, you can see the voltage across it. Oh, in fact, the voltage across it is not zero. So what I'm going to do, if I short circuit it, it will discharge the capacitor fully. So 9-volt power supply. I've checked it with the multimeter. What I'm going to do is I'm going to flick the switch and allow the capacitor to charge through the upper resistor. And I'm going to leave this filming the stopwatch and also the voltmeter so you can take readings for the charge at various time intervals. So let's do that first of all. I'm ready. I'm going to make sure the capacitor is discharged again, and then I'm going to flick the switch to charge it up and push the stopwatch so that the timer starts at the same time. You can take readings of voltage at a suitable interval. 3, 2, 1, go. Okay, so now what I'm going to do, I'm going to reset the stopwatch and then start the discharge. What I'm going to do now is I'm actually going to charge the capacitor quickly to 9 volts, or as close to as possible. Then I'm going to discharge it through the 100 kilo ohm resistor and start the stopwatch. 3, 2, 1, go. Okay, now we're getting towards a low voltage. I'm going to actually stop the stopwatch. So you should have enough data there to do the next part, which is to plot a charge and a discharge curve for the capacitor. You can follow the instructions in the practical sheet, and then you can use a log graph, in fact, to find the time constant and hence the capacitance of my mystery capacitor with your results. There's one thing left I'd like to do, and that is to measure the resistance of the resistors. Now, looking at these resistors in the resistance boxes, they have a color code on them, and these are gold stripes, which means, or gold stripes on one end, which means the tolerance is plus or minus 5%. So both should be within plus or minus 5% of the stated value. So the resistor I charged the capacitor through was this 47 kilo ohm resistor. So let's see what reading we get on the multimeter for that. 47.5 kilo ohms, and that's to the nearest 100 ohms, 0.1 of a kilo ohm. Next, the 100 kilo ohm resistor I used to discharge the capacitor, 102.4 kilo ohms, so you can see that's within 5% of the stated value. So you can use those values to help you work out your uncertainties later on the time constant and hence the capacitance. I hope that's been useful. Thank you very much.